Hey everyone, welcome back. Today we are going deep inside Proteus. Most tutorials just show you how to make a circuit blink on LED or simulate a microcontroller. But have you ever wondered what actually happens inside the Proteus when you click run? In this video, I will explain every steps from reading your circuits to showing results on the oscilloscope so that even if you are a complete beginner, you will understand exactly how Proteus simulates your circuit. The first thing Proteus does after you click run, the first stage is a design data collection. Is reading your schematic. It looks at every components you placed like registers, LEDs, ICs, microcontrollers, wires and the connections. Each component in Proteus has a mathematical model. These models tells Proteus how the components behaves in a real circuit. For analog components, it's a spice model, and for the digital components or a microcontroller, it's a built-in virtual representation. For the first example is the register model, which can calculate the voltage drop, which is equal to a current into resistance. The second example is a LED model, which knows that it lights up only when the current flows in the right direction. The third example is a microcontroller model, knows how to read the code instructions and sets its pins high or low. Proteus also prepares virtual instruments like multimeters, oscilloscope, which will later measures voltages and currents during simulation. Like that. This is the virtual instruments, that is oscilloscope, DC voltmeter, DC ammeter, AC voltmeter, and AC ammeter, and all. The next, Proteus does something called a netlist compilation. What is a netlist? Imagine your circuits as dots connected by wires. Proteus converts these schematics into mathematical equations describing every voltage and currents in the circuit. These equations tells Proteus how electricity will flow through each components. It also checks for mistakes. Are all components connected to a power or ground? Are there short circuits? Is anything missing? If there is a problem, Proteus will either warn you or the simulation may fail. This is why proper wiring is a crucial. Now we reach the heart of the Proteus, the simulation index. This is where Proteus solves all the equations from the netlist, calculates voltages, currents, and updates states of each components milliseconds by milliseconds. For analog components like registers, capacitors, LEDs, Proteus uses SPICE simulation model. This is the standard way to calculate the electrical behavior. For the digital components, the just like a logic gates, ICs, Proteus uses the digital solvers that calculates high and low states for each logic pins. If there is a microcontroller in the circuit, Proteus runs your program code instructions by instructions, updating the virtual pins according to the code. Just like, for example, the blinking LED circuits, microcontrollers code sets pin high, Proteus calculates the currents and LED lights. Code sets pins low, Proteus recalculates all the currents, LEDs turns off. Oscilloscope shows voltages rising and falling in the real signals. Imagine a tiny scientist inside your computer watching every electron, checking voltages, flipping switches, and running your code at the same time. That's the Proteus. After the simulation engine calculates everything, Proteus displays the result on a virtual instrument. This includes oscilloscope, which shows the voltages over time, and a multimeter like AC ammeter, AC voltmeter, DC ammeter, DC voltmeter that shows the voltage and current or the resistance. And the logic analyzer shows high and low states for digital signals. These instruments are virtual, meaning they are not real hardware. They just display what the simulation engines calculates in a real time. For example, the virtual DC ammeter can be shown in this example. Explain how the values comes from Proteus solving the equations. This ammeter shows the 0 ampere because that voltage drop in that circuit is very negligible. So it shows that these virtual tools are like the eyes of the tiny scientist inside Proteus. They let you observe the circuit without touching real hardware. Now we discuss the common errors during the simulations. Sometimes simulations fail. Uh, Here's why: missing connections. Proteus can't calculate the current. Wrong components values. So the LED won't light or voltage looks wrong, conflicting the signals. This is where the two outputs trying to drive the same node. That's understanding how Proteus works internally helps you troubleshoot these issues easily. Let's summarize the Proteus simulations process. Proteus reads the schematics and load the components models. It compiles the netlist, converting the circuits into equations. The simulation engine calculates voltages, currents, and microcontrollers states step by steps. The results are displayed on virtual instruments, showing exactly what happens in the circuits. You can now understand why simulations succeed or fail. Now you know what happens behind the scene. But why is simulation so important? First one is safety. You can test circuits without burning the components. Second is the speed. You can quickly test multiple designs. Third one is a learning. You can see what's happening inside every component, which is impossible on a real breadboard. Proteus essentially gives you a full electronics lab on your computer, when you can experiment freely and understand electronics deeply. Proteus has amazing debugging tools that helps beginners and experts alike, just like breakpoints, that can pause simulation at a certain point. The probe points. The probe points that can measure voltages and currents at any node. The variable watch that can monitor internal variables of a microcontrollers. The step executions that can run microcontroller code instructions by instruction. These tools let you see exactly what is happening inside the circuit, which is crucial when your design doesn't behave as expected.